9F, quadratic equations with discriminant less than 0. In our last section, we learned that if the discriminant is less than 0, then the graph had no x-intercepts, and that there was no real solutions to the equation. But in fact, there are solutions, and we can find them. They're just not real solutions. They're complex solutions. In 1572, an imaginary number was discovered. I is what we call the imaginary number, and it is equal to the square root of -1. Just like pi is 3.14, etc., I is equal to the square root of -1. We call it imaginary because we cannot place it on the number line. It is not an imaginary number. The number does exist. We just cannot place it on the real number line. When we get solutions to our quadratic equations where the discriminant is less than 0, these solutions are considered complex solutions because they're made up of two different parts. They're made up of a real part, a real number, and an imaginary part, a number with an I in it. So let's practice just figuring out imaginary numbers. In number 1, let's write in terms of I. We're taking the square root of -1 out. So that's going to be square root of -5 is equal to square root of -1 times 5. So I can rewrite that as the square root of -1 times the square root of 5. Well, the square root of -1 is defined by I, and then we have square root of 5 left over. So our solution to this radical is I times the square root of 5. In example 2, we have the square root of -16. You can write -16 as -1 times 16, or the square root of -1 times the square root of 16. Square root of -1 is I, the square root of 16 is 4, so we usually write this as 4I. So if we have a radical, we write the I in front of the radical. If we have a whole number, we write the I after the whole number. We know how to find the imaginary part of complex numbers. Let's see how this applies to quadratic equations. So our first example, this is a form of x squared equals k. So we would write x is equal to plus or minus the square root of -9. So that's equal to plus or minus the square root of -1 times the square root of 9, which we would say is equal to plus or minus I times 3, or x is equal to plus or minus 3I. In example 4, all we need to do is subtract 13 from each side, and we have it in the form that we can solve for x by taking the square root of each side. And then let's take out the imaginary part. So I have x is equal to plus or minus the square root of -1 times the square root of 13. So x is equal to plus or minus square root of -1 is I, and square root of 13 is just square root of 13. Now in example 5, we have a quadratic equation. Now look and see, I cannot solve this by factoring, so I'm going to try the quadratic formula. I let a equals 1, b equals 2, and c equals 2. Plugging this into our quadratic formula opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, and then simplifying down the equation, let's see what we end up with. So we have x is equal to -2 plus or minus square root of -4 over 2. So now we can deal with that negative underneath the square root by rewriting it as -1 times 4, which is equal to plus or minus I times the square root of 4, which is 2, so I can just write that as 2I over 2. Now remember, complex number is made up of an imaginary part and a real part, and we write the real part first. So the first thing I want to do is I notice I have a GCF on the top, so I factor out the 2, and then I rewrite this as -1 plus or minus I. So notice I have the complex number, which is composed of a real number, plus or minus an imaginary part. Make sure you always break it up in that form. Let's try one more example. In example 6, again, I cannot solve this by factoring, so I'm going to start by doing the quadratic formula. A is 2, B is -1, C is 3. So plugging those numbers into my quadratic formula and simplifying it down results in x is equal to 1 plus or minus the square root of -23 over 4. Now -23 can be rewritten as plus or minus I, the square root of 23, since square root of -1 is equal to I, and that's divided by 4. Now, we want to rewrite this as we have a real part and imaginary part. So in this case, we break up the 4 and we have 1/4 plus or minus the square root of I over 23/4. Remember to write your final answer in the form of the real number plus or minus the imaginary number.